Hello, everyone, and thank you for joining us. My name is Juliet, and I will be the moderator for today's webinar. Before we dive into the content, let me cover a few housekeeping items. At the bottom of your screen are multiple engagement tools you can use. All tools are resizable and movable, so feel free to move them around to get the most out of your desktop space. You can expand your presentation area or maximize it to full screen by clicking on the arrows in the top right corner. If you have any audio or video issues, you can find answers to some common technical issues located in the Help widget at the bottom of your screen. Please note that a copy of today's slide deck and additional resources are available in the resource list. Please have a look and download everything that you may find useful. Also, the webinar will be recorded and sent via the email you registered with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We are here to answer you live via the chat, so don't hesitate to reach out throughout the presentation. And with that, I'll pass it over to you, Steven.
Thanks, Juliet. Okay, so welcome to today's webinar on achieving success in energy storage development tips and best practices. So for today's webinar, we're going to dive into some essential topics that are going to be very important for successful and safe energy storage system development and successful certification. So our agenda really is going to cover a few areas, including key tips for achieving certification with UL standards and development best practices, Jama Software's perspective on development challenges, and the effective use of Jama Connect for managing the development of energy storage systems, as well as a sneak peek into our new energy storage development framework. Now, before we get started, I'd like to briefly introduce myself and my background. My name is Steven Meadows, and I'm a Principal Solutions Lead here at Jama Software. With a pretty robust background in requirements management, I bring around about 10 years of experience in implementing software and working with hardware and software teams across a broad spectrum of industries, helping important market game changers really succeed in their development efforts. Now, throughout my career, I've had the privilege of working closely with many incredibly innovative and life-changing organizations, helping them navigate the intricate landscape of engineering. So Jama Software, my focus has been on empowering teams to achieve their project goals efficiently and with precision. Whether it's harnessing, the full capabilities of Jama Connect, the platform, or strategizing for complex project scenarios and engineering scenarios, my passion really lies in delivering tangible results that drive innovation and enhance operational excellence. Today, I'm excited to be joined by Chris Flueckiger, who will be talking about energy storage development best practices and certification tips. He's a bit of a guru in the space. Would you like to introduce yourself, Chris?
Sure, thank you. It's nice to meet everybody. I've spent about the first half of my career working with the design phase of electrical equipment, and then the past almost 30 years in the certification of renewable energy systems, including battery energy storage systems. So I've been working with large companies. I work with all the certifiers currently and represent companies as they look towards certification, all the way from the concept and design of a product through the final certification and marketing and installation. So I look forward to talking with everybody.
Awesome. Yeah, happy to have you on here. So I'd like to spend a moment or two here quickly introducing Jama Software, the company that I represent. So Jama Software provides a suite of solutions that really support more efficient and safer product and systems development practices, from capturing and managing requirements traceability to ensuring seamless collaboration across different teams that involved within the development process. Jama Software has really engineered a platform that aligns with the evolving needs of today's businesses. And so you'll see on this slide some of the verticals that we support, including, regulated industries like medical device and aerospace and defense, as well as pure software engineering, and also industrial and energy systems development companies too. So some of the ways that we really help our customers actually realize value is by reducing project cycle times, increasing process efficiency, and gaining visibility and control throughout development. And really our sole purpose is to ensure that innovators succeed. Okay, so with that, I'd like to hand over to Chris at this point, who will be walking through some very insightful tips around energy storage development best practices and key tips for achieving certification with UL standards.
Oh, thank you very much. This is going to be interesting. In a half hour, we're going to try to cover the complexity of certification, but to do so in a way that'll provide efficient moving from the development of a product to the marketplace. And this is an image of that process when we talk about certification. It starts with a list of documentation, a knowledge and understanding of what applies to your product. And to go back just one step, it's understanding what your standards and codes are that are driving that certification of your device. You'll see the blue text here that represents work that you can do ahead of time to ease the process of certification when you actually present your product to the certifier. And this blue information here is a collection of documentation and evidence, if you will, that your product indeed complies with whatever standards might apply. When we're talking about energy storage systems, we're looking primarily at UL 9540 and UL 9540A. And the code that drives that is going to be the NFPA 855. And so all these little blue boxes are critical as we prepare for our submission for certification. I will say that not having this information as you enter into certification results in significant time delays, resource costs as far as samples needed, retesting, redesign, etc. And so what we're going to do is go through some of these critical points here and discuss how we can make it easier, what we can do to prepare better so that we can be as efficient as possible. Just an example of how efficiency can help you. A typical certification of an energy storage system is going to take about, well, it could be anywhere from 14 to 16 weeks. We've had some certifications that have taken more than a year to complete when they haven't prepared properly, or they've had to redesign, or test results have come back that have showed a lack of compliance to the UL 9540 standard. So it's critical that we move forward in a smart, organized, and efficient manner. Talking about the beginning of this whole process is a knowledge of all of your codes and standards that apply to your energy storage system. You know, it's more than just a marketing scheme. It's a legal requirement that devices are certified or proven safe to the authorities having jurisdictions, or AHJs, that approve those installations in one of the many, approximately 3,000 different jurisdictions across the United States. Those codes are called out by the building codes, and from there it calls out specific codes for electrical and for fire safety. And those codes are adopted by local jurisdictions that give them some teeth, right? They're legislated into effect, which gives them the legal basis as a requirement in order to install an energy storage system within a particular jurisdiction. And that legal basis is important. You know, when we talk about certification, often companies see it as a necessary step, maybe even an obstacle that they have to achieve just to get their product to market. But it has more meaning than that. It basically is establishing a bar of entry for electrical devices that are suitable and acceptable for installation in specific jurisdictions. Now, in the United States, we fortunately have the NFPA 70, or National Electrical Code, that drives those requirements for safe electrical equipment. And that follows through along with the fire codes. So there is that legal basis for doing this. And yes, it can be time consuming and it can be costly to go for certification, but it's a necessary step in order to demonstrate that our products meet the industry standards for a level of safety. And we do that basically as a consensus agreement within the industry on the requirements that are established both in the codes and in the standards. So it's not simply a check off. It is an integral part of the safety of our electrical systems in the United States. And if we could go to the next slide.
Sure, yeah. Chris, I actually have a question on this as well.
Sure.
Have you worked with teams in the past, maybe missed the upfront research around codes and standard requirements, and any examples of some of the impacts of that?
Oh, absolutely. And oftentimes they're, as I say, they're kind of looked at as a necessary evil and kind of bypassed, if you will, during the design phases. And then they come back later with those requirements and try to implement them at the last minute. And that often requires redesign of electrical circuits, repackaging of the product, et cetera. So it can be rather detrimental and costly to wait until the end.
Sure.
Yeah. Good question. So when we look at typical requirements that are included in the standards and the codes, we'll be referencing UL 9540 quite often here. They're broken down into three major categories. We have your general construction requirements, and this is your design, right? This is the components that you're putting together into a package that are providing whatever functionality you're advertising or you're stating that your energy storage system will provide. For example, you may have a input voltage of 480 volts. You might have an output voltage of 120 volts, whatever the case might be. And you may have a certain amount of energy storage, number of batteries in your system that operate in a certain way to provide either backup power or to even maybe clean up a microgrid someplace in an industry, for example. But all of those general requirements for those ratings rely on a construction. Everything from the wire nuts holding two wires together or the connectors, all the way to the batteries and through the whole system with cooling systems potentially and other systems that make up a part of the whole system that you're looking to market. And so those general construction requirements are basically material type requirements, component requirements, mechanical requirements, and all of them are specified or delineated in UL 9540.